I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. Today I'll talk about using the TikZ fit library to create metanodes that can frame a set of existing nodes. I'll also explain how to bump out some sides of the frame if needed. The fit library is useful in conjunction with the backgrounds library, enabling us to layer the fitted nodes appropriately. I'll demonstrate the utility of the fit library combined with the background and other libraries and an example tensor network diagram. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Our focus today is on the fit library. Here's the preamble for the document we'll create. The geometry package is used to set the paper width and paper height to sizes that are convenient for our episode today. Parsegift is used to make the paragraph spacing nice, and hyperref allows me to provide a clickable link to this YouTube channel. The essential package is TikZ, and we'll cover several libraries to do with that. The fit library is the star of today's episode, allowing us to create nodes that fit around other specified nodes. The background library helps us to draw things on a layer behind the main drawing. It's often used in conjunction with the fit library so that you can put the fitted node behind the nodes that it's fitting. The positioning library is for easily placing nodes relative to each other. I have another episode on that I'll link in the show notes. And at the very end, we'll just use arrows.meta a little bit, and I have another episode on that, which I'll also link in the show notes. Let's start with a basic example of fitting a node around several other nodes. First, I'll set up a TikZ picture with a few simple nodes, A, B, C, and D. For the positioning library, I'm setting the node distance to be 5 millimeters vertically and 10 millimeters horizontally. The default is that both distances are 10 millimeters. I create a style named Basic for the nodes, which sets their fonts to be large. I'm placing the nodes relative to one another using the positioning library. So I start with node A. I put node B to the right of A, node C to the above right of B, and node D to the below right of B. When I compile that, we see our 4 nodes, and then we can think about putting something around them. Now, to create a node that encompasses A, B, C, and D, we're going to use this new option, which is called fit. We simply list the nodes we want, each name contained in parentheses. So for our new node, which is going to fit everything else, this is the command. The node doesn't have any contents. I'm drawing the outside, and then I just give the list of the 4 nodes that I want to have fitted. When I compile that, we see we have a container for those 4 nodes. Now I can add draw equals red up here to the basic style so that you can see a little bit what's going on. It may not be entirely obvious. When I compile this, you can see that there's a little extra space around these nodes. And that's because this node we created that is fitting everything else has a little bit of inner separation by default. If we want to change that to say have no separation, we can set the inner sep to 0. When I recompile that, we can see that now the frame is tight. Fitting works even for circle nodes. Let me change the shape up here to be circle. So A, B, C, and D will be circle nodes. And now that fitted node has been updated so that it captures the entire circle nodes. Now I can also color in this fitted node. So I can put fill equals yellow at 10%. What happens now is when I compile it, it covers the original nodes. So that's a problem. This is why I mentioned in the beginning that we need to use the background library. So I can fix this by putting this fitted node on a background layer. So I'll get rid of this and just replace it with the same thing, but now inside the scope, which has on background layer in its options. Everything else is the same. And when I recompile that, now we have our fitted node behind the nodes we want to frame. So there you have it, a meta node that neatly contains the other nodes. Sometimes you might want to include some extra space around particular nodes within the fitted node. We can achieve this by creating additional invisible coordinates and including them in the list of fitted nodes. I've recreated our prior example for use in demonstrating how to achieve this extra space. Suppose we want more space to the left of node A, but we don't want more space everywhere else. We can use the path command to create an extra node relative to A. So I do that by starting at A.west and going 2 millimeters to the left. When I compile that, we see that I have a little line here because I use the draw option. And then I can add that new coordinate. Now I've expanded that fitted node to fit that extra coordinate. Finally, I can remove this draw option. I just did that so you could see it. I'll include a link to the episode on coordinates in the show notes. Let me show another example, making a little more space at the top of the fitted node. Here I'll make a node called CC that's 3 millimeters above the node C. And then I'll add this to our list of fitted nodes. And now we've made a little extra space on the top of that node. I'll note that if you want the node to expand the same amount in every direction, you should instead use the inner separation option, and you can just add padding all the way around. Let's look at a more complex example, recreating a tensor network diagram. This example will showcase nested fitted nodes and custom styles. This diagram is inspired by one that I found online at the Quantum Jet documentation, and I'll include a link in this document to that documentation. Let me go ahead and paste what we have here. It's quite a bit. So I'm going to start off by adding that link, and then I define a bunch of colors so it looks the same as the picture that we're mirroring. Then we'll define some special styles with TikZ set. I'm using the circ style to define the main type of node. These nodes will have their outline drawn, and the outline will be thick. I'm passing in the color as an argument to this style that we're defining. And I cover using styles with arguments in another episode that I'll link in the show notes. We're making these circles. The minimum size is set to 1.4 centimeters. And I played around a little bit to make sure that was just enough to fit the text I wanted, but not so big that it was oversized. I set the inner separation to 1 pt. And then the node font for all the nodes will be large. I'm also defining something called index, which will be used as the style on the edges in our tensor network diagram. I'm going to make every edge thick, and then I'm setting the node distances when I'm using the positioning library to be 3 millimeters vertically and 12 millimeters horizontally. So now let's look at the code for the diagram itself. Let me go ahead and compile this so you can see the result. I have here a node A, and then to the right of that, I create a node B. That has an edge back to A, and it's labeled with M using index and above. Then I'll create another node C above right of B, and this node will have an edge back to B with the label of I. Then I'll create another node D below and right of B. It will have an edge back to B labeled J, and another edge to C labeled with K. And then finally, I'm adding this extra little line out to the side and labeling it with N. I'm using for the style of N the index, which has the positioning being a default of midway, but I'm actually overriding that here with pause equals 1, which is saying to put it at the end of the line, and then I'm putting it above left of that last point, and that's where the end goes. Now let's build the version with the fitted meta nodes. First, I'm going to define 2 more styles up here. So I'm going to define the style fitted, and that's going to take a list of the nodes that would be passed in as my argument to this custom style. And then it's going to draw the outline in gray. That outline is going to be densely dashed. I'm going to fill the node, but I'm only going to fill it at 10% opacity. And then I'm setting the inner separations in both directions to be 1 millimeter. I could have done that with one command, but this leaves some room to play around with the X and Y separation. Second is the fit label, which I'll use to put the text in the upper left corner to mirror the image that we're trying to copy. Now let's add our first fitted node down here in the picture itself. So I'll go ahead to the end here and I'll paste some code that will put this fitted node onto the background layer. Technically, the coordinates CC and DD don't need to be in the background, but I'm just putting them there because it doesn't really matter. I'm putting the coordinate CC at an angle of 135 and 5 millimeters out, so just about here, and another node DD that's a little bit over here to the right. And then I'm drawing a box around C and D, and so let's see what happens when we compile that. Now we get our node boxing these and in the background. And then I've added here the node label of sorts up here in the left-hand corner. All that stylizing so that I can make sure it goes in the left corner is done with fit label equals CD. Now we'll add the next node. This is going to go around B, C, and D. So here we have that. Let's compile that. Now what you can see is that down below and to the right, it is a 1 millimeter gap, which is sort of looks like the picture we're trying to emulate. But I've added again a little extra space here, creating the node BB to scooch things out a little further as before. Technically, I'm plotting this new node right on top of the CD node. They're both in the same background layer. This is okay because I've set the fill opacity to be 10%, so the nodes are semi-transparent. If I needed to, I could create a bunch of layers and make them separate. And if you want an episode about using multiple layers, not just one background layer, let me know in the comments. Finally, I'll add the last wrapper node here, and that will wrap the whole bunch of these nodes with a sort of meta node that we call E, and this is wrapping around everything. Again, I give a little extra space to the left of the node A by creating a coordinate AA and including that in my fit. Finally, I'll add a last little bit to reproduce the last bits of the picture that we're trying to emulate. Let me add some code after this scope. The first coordinate here takes the y coordinate from A dot center and the x coordinate from n dot west. So this is the n node and this is the A node. Then we advance 1 centimeter to the right. That's what this little part does here. And then we're drawing an edge from that point over to a point 5 millimeters away. And we're making that thin. And then here's where we're using our arrow. We have a bar at the start and a scaled arrowhead on the right. And then we'll go advance another 1 centimeter and create an E node that we set to the right of that point. And then we lastly draw a little line like this one coming out of this E node. The final result here is a tensor network diagram that's showing that if I contract the nodes as shown here on the left, we get this new node on the right that just has one leg sticking out. I'll link to videos that explain the coordinates and arrows in the show notes. I hope you enjoyed today's episode on using the TikZ Fit library to create meta nodes. The final example demonstrates the power and flexibility of the Fit library, especially when combined with styles, background layers, and careful coordinate placement for creating complex layered diagrams. I'd like to do more episodes showing complex diagrams. If you have any diagrams you'd like me to cover, please leave a comment. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. That really helps with promoting these videos. If you have TikZ or PGF plots questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.